So we're talking about solving a system of equations. We're going to use three different methods today. I'm going to teach you how to use the substitution method, the elimination method, and solutions by graphing. So we're going to use the same system of equations for all three so that we can compare them equally. Let's start with the substitution method. So a substitution, we solve an equation of our choice, and then we substitute one value for another. So I'm going to solve this top equation here. So I'm going to divide everything by 5, and that would give me 2x plus y equals -1. The reason I decided to divide everything by 5 is now I've got y by itself right here, which will allow me to solve by moving 2x to the other side. So these will cancel. And I'll be left with y equals 2x minus 1. So that -2x minus 1 that we're seeing will be used as my substitution. So where I have y here, I'm going to use -2x minus 1 instead. 3x minus 2 times, that's where that will go, is equal to -12. So I'll plug that in, -2x minus 1. Now I have an equation with only one variable. When I have a single variable equation, I can solve it. So I'm going to distribute the -2. Negative times negative is positive, so that's positive 4x, and positive 2 equals -12. Combine like terms, so 7x plus 2 is -12. Finally, use the reverse order of operations to solve this equation. So 7x, those cancel, it's -14, or x is -2. Now that I've found x, we're going to go back to a substitution system. Everywhere I see an x here, I can plug in y equals -2 times -2 minus 1. Y equals positive 4 minus 1, so y is equal to 3. Well, now I should have my solution, which is going to be an ordered pair. So my solution to this problem is -2 comma 3. So that's how you would work a problem like this using the substitution method. Substitution works well when you're easily able to isolate a variable. Like right here, I was able to isolate y by itself by dividing everything by 5 and moving all the other terms to the other side. When I had y by itself, substitution became very easy. Substitution does not work well if I'm not able to isolate y, or if isolating y produces a lot of fractions. Generally speaking, students struggle with fractions, and it just makes the math a lot harder. So this is only useful when you're specifically able to isolate y easily or easier than any other method. Let's look at our second method, and that's going to be elimination. The method of elimination says, if I can add these two equations together to get a new equation and get rid of one of the variables, I can solve it. So what I'm going to do is I'm going to change both equations here. And I'm going to go ahead and my plan here is that I would like to see the y's cancel. So I would need to find the least common multiple of 5 and 2, which is 10. So with that least common multiple in mind, I need to make that 5 10, so I multiply it by 2. I need to make that -2 -10, so I multiply it by 5. So I have to multiply everything. So 10 times 2 is 20x, plus 5 times 2 is 10y, equal to -10. I multiplied everything by 2. Down here, I'm going to multiply everything in the second equation by 5. 15x minus 10y is equal to -60. Now I'm going to go ahead and add those equations together. So 20 plus 15 is 35x. Here, positive 10y and negative 10y cancel each other out. That's exactly what I hoped would happen. And then here I have negative 70. So I'm just going to go ahead and move that back over. And my last step is to divide both sides by 35. Well, these cancel. And 70 divided by 35 is 2, so negative 2. The same number we got before. Now, we have to go back to one of our two original questions and plug that back in. 3 times negative 2 minus 2y is equal to negative 12. That is negative 6 minus 2y is equal to negative 12, and just keep solving it. Add 6 here, add 6 here. These cancel out, and I get negative 2y equal to negative 6 divided by negative 2, and that's going to give me that y is 3. So once again, my solution is negative 2, 3. So even though the method is different, the solution comes out the same. The elimination method works well in a couple of cases. When you have two numbers where the least common multiple is clearly known, so for example 5 and 2, it was easy to switch those so they canceled out. When you have one that's positive and one that's already negative, or if you had a case where you had like the same, like 2y and 2y, it'd be easy to multiply one of them by negative 1 and finish off the problem. So on cases like that, the elimination method is the best choice. So the last method we're looking at is solve by graphing. So we're looking at solving by graphing. So what we're going to do is we're going to solve these equations for slope-intercept form. So I'm going to start with that first one, which is going to become 5y is negative 10x minus 5. So y is negative 2x minus 1. And I'm going to graph it. I'm going to graph them each in a different color. So it goes to minus 1, and it goes down 2 over 1, down 2 over 1. So then I can connect all of my points. Like so. Now, let's look at that second one. So it's 3x minus 2y is negative 12, or negative 2y is negative 3x minus 12. And we need to solve it, so we divide everything by 2, or by negative 2. We get positive 3 halves x plus 6. So coming back over here, we want to graph that, same as we did before. So we made 2, 4, 6. I'm going to work backwards since I'm so high on my graph. So my slope is 3 over 2, which is rise over run. I'm going to work backwards, go 3 down, 2 back. 3 down, 2 back. I can see already that'll be enough to get my graph. So, already. Make that a little nicer. Oops. There we go. Something went wrong with my line entirely. We'll try that again. Oh, that last point is off. Right here. I went 2 down. So it should have been down here, like so. And that's what was going on. So you got to be careful when you sketch your points. And that will show you if you're not able to connect them with your ruler, like I was having trouble doing. That's what tells you you made an error. All right. So here, our solution is this point right here where they intersect, which is negative 2, 3. So again, we get the same point through any method we use. The benefit of the graphing method is that graphing is generally something you're already familiar with. It's very quick and it's visual. The disbenefit is if this is not a whole number. So like here it was -2 and 3, these are integers. If this is not an integer or whole number answer, if this is some fraction, it's very difficult to tell exactly what it is looking at a graph. Whereas with the other methods, you can tell exactly what it is without having to guess. However, graphing works very well for integer answers. It's also very nice because it allows you to visualize what's happening. This is where the two lines cross. It's the only place they will cross. So those are the 3 methods we're working on for today. Y'all have a wonderful day.